consider our limits what our book would say is at infinity. I would say to infinity, infinitely to the right and infinitely to the left, positive infinity and to negative infinity, asking ourselves what the y's are doing. Question. What's an example of a function that as you go to the right or to the left will go to positive infinity or negative infinity? Someone show me a function real quick. It's a function that would go to positive or negative infinity as you go to the right or to the left. Just pause. Why not 3x plus 2? 3x plus 2, what happens as I go to the right? Positive infinity. What happens as I go to the left? Negative infinity. Okay, give me another example of a function that as you go to the right, to the left, the limit as x approaches infinity or negative infinity, it would go infinitely up or infinitely down.
X cubed.
X cubed. As you go to the right, what's the limit as x goes to positive infinity? Because as you go to the right, what are the y's doing? They're going to positive infinity. They're increasing. And then as x goes to negative infinity, what's the limit? Because as you go to the left, what's my function here? Exactly. What if I was to give you something? Here's an interesting one, and since you're in honors, I can give you spiders to crazy stuff. No idea. Question.
Sure.
Use a good marker.
Wow.
Someone like this.
Big fan.
Oh, that's a full trash can. It's not gonna work.
Yeah.
Oh!
The thing is open.
Limit. I had the coordination. Didn't help. I was tall. That kind of helped, but no coordination. What?
It's okay, I'll take half the NBA.
Okay, Charles.
They have some coordination, just not immense. Question. We give you another function. You guys aren't used to him, huh? Let me give you a better one. You guys have seen e to the x, right? I saw some of your eyes when you saw the 3 to the x. E to the x, what's he look like? That's Owen. Everybody look at Sean. What's e to the x look like? Yep. It's a short. Okay, so.
Okay. I had coffee today.
Okay.
That's e to the x, yeah? Just say yeah. Everybody's at e to the x?
Yes.
Yay! No. Okay, question. What is the limit as x goes to infinity of e to the x, e to the 2, e to the 5, e to the 10, e to the 100? What's it doing? As you go to the right?
Right, you go to infinity.
Yeah, the limit is positive infinity. If someone wanted to be tricky, they would use an exponential function because to the right, what are your y's doing? Going up. But to the left, what are the e's doing?
Going closer to 0, isn't it?
All the functions we've talked about so far, whether it was the line, whether it was the cubic, whether it's the parabola, if they're going to infinity one way, they're going to infinity the other way. Maybe up, maybe down. But if they're going to infinity one way, they're going to infinity the other way. Why are exponential functions funky? It approaches infinity one direction, but it approaches 0 the other. Does anybody know why?
Because of this, like, the negative, it makes it simple.
Let's take a little table. Remember the old-fashioned way we did limits of focus? How would you approach infinity? Oh, this was actually a question in homework.
10 to the 0, 10 to the 1, 10 to the 2.
Yeah, maybe 10 to the 0, 10 to the 1. You're like plugging in bigger and bigger numbers, right?
Yeah, that was not.
As you plug in bigger and bigger numbers, what's going to happen to this guy? He's going to get bigger and bigger and bigger, right? So he's going to be increasing without bound, and as he increases without bound, we say, yay, it's positive infinity. The question, how do I approach negative infinity?
1 over 10 to the 0, 1 over 10 to the 1, 1 over
Well,
10 to the
we could just write 10 to the 0.
But 1 over is sitting right here, though.
10
I want negative numbers. Does that make sense? So I could do
Oh.
negative 10 to the 0. I could do negative. Why am I going to do negative 10 to the 3? Well, I could do negative 10 to the 2, but what would some of you guys accidentally do?
That would be 10,000.
You can't put the negative on the inside, right? Okay, as I decrease without bound. This one, 10 to the 0 was e to the 1, because I plug in 1. 10 to the 1 was e to the 10, plug in 10. 10 to the 2 is 100, e to the 100. This one would be e to the negative 1, e to the negative 10, e to the negative 100. Sean, what were you talking about reciprocal?
When you have a negative exponent and it reverses into the reciprocal. So 1 over e to the 1 and 1 over e to the 10 and so forth.
Okay, guys, what have we learned about what happens when I have a bottom that's strong? Yeah, the bottom wins. My function is going to be approaching 0. It's going to be small and small. Now, why is this so important? Ready for a challenge problem?
Yes, oh, yes, sir.
Once.
Oh,
It knows. It knows enough.
right?
It's because he did it.
Okay, I'll give you one right here.
Not designed at all.
What if I do the limit? No, I'm not going to say that. No, I'll just write this one. I don't want to be as mean as I am with calculus. The limit as x goes to infinity. Degree test. You guys have them written on your notes, right?
Yeah.
What case do both of these fall under? They're both approaching, x is approaching infinity. They're just, one's going to the right, one's going to the left. How do we think about, with degree tests, these functions? What do you guys think? Top ends, bottom ends, or tie? Why tie? But I agree.
Okay, because the base is the same as the base is the same.
Bases are the same, both to the power of x. So the pieces with x's have the same strength. Okay. Question. Which pieces, the 1 and the 7, which terms, the 1 and the 7 or the 3 to the x and the 3 to the x, should I be looking at as x approaches positive infinity? Okay. So, ratio of the leading coefficients, I'm looking at these guys and saying, hey, they tie. They both have an exponent of x and they both have like bases. So, whenever I have a tie, according to your degree test in your notes, and I'm trying to get the computer back up. According to the degree test in your notes, what do we do when we have a tie?
Look towards the coefficients and then the sign test.
Leading coefficients. And check the signs. So, leading coefficients, what are the coefficients in front of 3 to the x's? So, I'm going to have 1 over negative 1, which is going to be a negative 1. Let's double check our sign really quickly. So, we're going to check positive or negative. If I plug in 1 plus 3 to the infinity over 7 minus 3 to the infinity. And what do we talk about exponential functions when the powers are getting bigger and bigger and bigger? What's going on?
Positive, right? Just positive value.
Just getting bigger and bigger and bigger, more and more positive. So I'm going to have 1 plus bigger and bigger positives. What sign will that have?
Positive.
Positive. And 7 minus bigger and bigger positives. Negative. What's a positive over a negative? Okay, so keep it, you're good. Now what about the bottom one? What changes?
The checking on
Okay.
the side.
So let's check. If we were to check, we would have 1 plus 3 to the negative infinity over 7 minus 3 to the... What happens when 3 gets raised to bigger and bigger than negative?
Doesn't it become like positive because it like changes focus? Instead of you looking that way, to you, like that way you're looking down. So you're going positive down.
But what do exponentials do? Now this one's E, that's 2.71828, but that's 3, it's not that much different.
It'll still approach 0 because.
It's not going
it's-
down.
It still approaches.
It approaches 0. Now it is going to be positive numbers, that's true. But what kinds of positive numbers? Bigger and bigger, and so they win? Or smaller and smaller, so they lose? So I could go ahead and rewrite this to be, oh wait a minute, isn't that the same thing as why does that make a difference?
Because it doesn't turn into 0.
You had to go to 0.
As I'm taking the limit, that one's going to 0. That one's going to 0. Who's stronger as I approach negative infinity? Another way of thinking about it is I could rewrite this, and I could say this is the same thing as the limit as x goes to positive infinity of 1 plus 3 to the negative x over 7 minus 3 to the negative x. Which would be the same thing as plugging in a negative infinity, plugging in a positive infinity. They will end up being the same thing. Either way, who am I supposed to be looking at? The 1 and the 7. So what's the limit as I go to the left? You guys look at your drafting calculator, that function for me real quick. Does it make sense that I'm going to have 2 different horizontal asymptotes that do not agree? Does it make sense that I'll have 2 different horizontal asymptotes that do not agree?
I love the alpha. Why you guys?
Because there was a code, there was a code, and then I'm praying about the code, it was too late. It's like, hard to find
Okay, that's cancel out. What was the code that she
It's one of the songs on the oh, I skipped it. Did you really look at my phone?
Wait, who was the friend that knew the code? They should have gotten extra tickets. You guys should.
What's
I
that?
don't think she was either.
What you guys do?
Well, that makes you feel better, like if she knew the code.
Let's see.
This day.
We got like an asymptote at like 2.
No, wait, it looks good. It looks good. As you guys look at the bottom branch, right? As we get the bottom branch, doesn't it seem to be approaching a negative number? Trace it. If this is negative 1, doesn't it look like, where's your vertical asymptote?
Like.
Somewhere past 0?
Yeah, about 2.
Doesn't it look like it's approaching a negative number? As you go to the right?
But it stops. It stops.
Well, it's only able to approach so far. You have to widen your window.
So it's approaching negative 1.
So it's approaching negative 1 as I go to the right, which is what our math shows. And what's going on as I come towards the left?
Oh. That is smart.
It's approaching 1 7. But how hard would that be to see on the graph? Like it doesn't show you 1 7 little ding 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 horizontal asymptote here, right? Like it doesn't do that.
What's the vertical asymptote at 2?
Well, vertical asymptote, remember, is whenever the denominator equals 0. And so if I wanted a vertical asymptote, I would need this end. I know, you guys try to do this is very I thought that would be that one. Subtract the 7, divide by a negative. 3 to the x is equal to 7. How would you solve? You would take either log base 3, you could do ln at both sides, right? So Luca, check it out. What's ln of 7 divided by ln of 3? I bet it's 2-ish.
7, 7, 3. 1.75, yeah.
See what I mean?
Yep.
So that's what the vertical asymptote is. That's what
Wow.
the denominator equals.
I feel exposed.
That was cool.
It's a crazy function, it's not an easy one.
That was
Yeah.
cool.
Nice thing is my notes are back. Guess what? I have easier examples in the notes. Ready? And you guys should already write these down. Let's go ahead and solve these easier examples. You've seen a harder one on the board where it does make a difference to check the sign. Where it does make a difference to check the sign. Let's see some where it's a little bit more basic. We like basic, right?
Yeah.
So, basic. Question. Top wins, bottom wins, tie. Tie. So, tie.
Check this one.
When you plug in,
So -1 over 1.
-1, careful. Right? -1. Now we think -1, we can check the sign if you want. And remember, I'm just preparing you for harder problems. And the trick ones that they like to put on like random AP tests. Doesn't mean it's everyone. But to check the sign, we could think of what's 1 minus bigger and bigger positive, oh not negative infinity, sorry. 1 minus positive infinity. And then 1 plus positive infinity. Once again, this is fuzzy math. You're just thinking, as the numbers increase without bound, what's the sign on top? Negative. Okay. And what's the sign on bottom? Yeah. What's a negative over a positive? A negative. Number 18. Top wins, bottom wins. Hi.
Top.
Top wins. Hold on, check out your degree test. What is it in the top one?
Don't have to multiply by 1 over y squared.
We could. We could. You have two different options. You can use the degree test, or you could multiply everybody by 1 over y to the 4th. That's how I would do it. There is a mathy way to solve these. You don't have to do it the mathy way. The mathy way says 4y to the 4th over y to the 4th is 4. Y squared over y to the 4th is 1 over y squared when you distribute. And then 3 over y to the 4th. At the beginning of this section, notes, question. What do we know about the limit of a constant over y to any power?
So y would be 0, right?
This is approaching 0. Constant over y to any power, this would be 0. So I'd end up with 4 over 0. Isn't that undefined?
Oh. That's when it
Number
shows up
over 0 is a vertical asymptote.
Okay, so then we have to check.
Vertical asymptotes.
So you have 2 vertical asymptotes.
Well, we could check from both
Well,
sides.
hold on. Vertical asymptote, you guys are. In math, when you get a number, the number is a number. When you get 0 over any number, what does that mean? 0 over 1, 0 over 10, 0. When you get 0 over 0, what does that mean for limits? Undefined, the function is undefined, but keep
Undefined
going.
sometimes.
Yeah, undefined sometimes when you keep going. What happens when you get a number over 0? Undefined, can't keep going, something infinite. Something infinite. Now, guys, look at your degree test. Pause. You wanted to do the whole mathy thing. You did. But pause. Look at when the top wins. What's the answer every time? No horizontal asymptote because what's the function doing? Approaching infinity or negative infinity. Look at your degree test. Hold on. Right. If the top wins, right? If the top wins, what's my limit going to be? Positive or negative infinity, check the sign. If the tie happens, ratio of leading coefficients, check this out. And if the bottom wins, what happens? Okay, so come back. The math, whenever you get what we call infinite form, any number over 0, we always know the limit is going to be uninfinity. But we need to check the sign.
Yeah, but that's what I said yesterday. It looks like the bottom wins, but actually you should flip it, and then the top wins.
Look at the bottom one.
No. Because 1 over y squared plus, remember you considered that it goes to 0? But if you, actually the top wins because if you flip it.
I thought we were just looking at powers though.
Here's the problem. In order to be able to flip it with the
Yeah.
we have to put it over 1. So then we would multiply by, or we would say this is the same thing as 4 times 1 over y squared plus doesn't change anything. You would flip these two. Or the other way to do it would be get common denominators.
Oh, then good luck.
See?
Yeah.
Then you would have 4 and you have y squared plus 3 all over y to the 4th. Then you would have 4 times y to the 4th all over y squared plus 3. But see how that's the same thing that we had at the beginning? It didn't work yesterday because
Yeah,
You're
it
just
was,
trying
it was
to-
a different problem.
you're
Yeah.
trying to flip them separately, but forgetting that it's all one piece. Does that make sense?
Yeah.
So if we can get it put together like this, then we flip, but it's the same thing we had to begin with. So I see what you're saying, it's just, it's making it too hard.
Or illegal.
And if you do it illegally, then it can make it wrong. Does that make sense?
Yeah.
How do we check the sign? Okay, focus. How do we check the sign?
Just like.
Yeah, imagine plugging in kind of bigger and bigger positive numbers raised to the 4th power over bigger and bigger positive numbers squared plus 3. What's the sign at the top? Positive. Is a positive to the 4th times 4 is a positive. And what's the sign at the bottom? Yeah. So whether it was negative or positive infinity doesn't matter. A positive over a positive, I need a positive infinity. So we get the infinity from the degree test, top wins, right? We just have to check this sign over here off to the side. We get the ratio of the leading coefficients from the tie. We just double check the sign off to the side, right? So we have negative 1, we have positive infinity. What do we do in number 27 when we have little bits and pieces? Don't say distribute, but I like the idea. We're going to take the limit piece by piece. Take the limit piece. You could get a common denominator if you really are feeling it, but I think I like just taking the limit piece by piece.
Oh.
Don't say distribute just because it's not multiplication,
Okay.
but I like the idea.
Okay.
Piece by piece. What do you do with the left
Because
one?
I've been doing this.
You could, and then 1 over bigger and bigger numbers is going to go to 0. Is going to approach 0. The bottom wins 0 minus tie.
So 5 over 1.
Good. 5 over 1. Now we could double check the sign real quick and say, okay, hold on, if we have 5 times positive infinity.
It would just be.
Good. 5 times positive infinity over positive infinity plus 2 is going to be a positive over a positive. Minus positive 5, and what's 0 minus a positive 5? Does that make sense? So let me give you one tricky one, and let's see if you guys will carefully check this out. Okay, what if I was to give you ready? That's the one thing I was worried about. You guys know that.
Yes.
Oh no, it's wrong.
Challenge. You ready?
Oh no.
What if I want you guys to think about the limit? As x goes to O, negative infinity of the absolute value of 2x plus 1 all over 3x. Okay, what do you guys think it is? Talk it through with me. I hear things about ties, I hear things about absolute values, I hear things about
Well, it's a tie, but the coefficient is the problem.
Okay, so it is a tie. Hold on, go back to your degree test if you don't have it in your head. When I have a tie, what do I think about?
coefficients.
The leading coefficients.
She knows what I'm saying.
But what do I still need to do? Okay, so what happens when we check this out? This 3 is times a negative infinity, right? All over. What's on top? You guys agree? So a negative over a positive would be a? A negative over a positive would be a negative. So, oh, I get it. Anytime you have the limit as x approaches negative infinity, it's going to be a negative answer,
How
right?
did that bottom become a positive?
What if I give you this one?
So. Yeah, right.
Yeah.
Just kidding.
Yeah.
I didn't know
If it's not,
Yeah, you know the school.
In all reality, they're a tie because a fourth degree square rooted is the same degree as a square. Does that make sense? A squared is a fourth degree. So since I have a square root, they're tied. So now, what do you guys think for your coefficients? Does that kind of make sense?
Yeah.
We could do the math and multiply it on the bottom, blah, blah, blah. Okay. But what else do we need to do? Well, the one up above, no big dealio. Like, you had a negative infinity, it was a negative. Like, we should just put a negative and be done with it. Except, when you plug in a negative here, it's squared in the bottom, it's to the fourth, and then it's square rooted. What's the sign on top? Negative square root positive. What's the sign on bottom? So we're going to say definitively and know that we're right? Does that make sense?
Yeah.
Anyway, so, kiddos, the last part of homework, which probably won't even be on your quest, but if you want to look at it, we've talked about converging and diverging this year, right?
Oh.
If we were talking about sequences, this is actually a Calc BC thing. We don't see sequences in series.
What's
Going back.
Let's do it.
A sequence separated by commas. One term, comma, another term, comma, another term. Will converge if the limit of the sequence is 0, and will diverge if the limit of the sequence is anything else. So basically, we're only going to positive infinity because sequences don't go to negative numbers. They only go to first term, second term, third term. There is no negative fifth term. So if they give us different sequences, all we need to say is, oh, you want us to take a limit of that? You want us to take a limit to infinity of that?
Yeah, let's go.
So what's the limit to infinity of letter A? We say find the limit.
It's
Big
a
E.
tie.
It's a tie.
So it's 2 over 1.
And we're only plugging in like positive numbers, so it'd be a positive over a positive, so we just have positive 2. What does that mean in context? Sequence diverges. But we're trying the limits, so let's keep going. How about for the second one? What's the limit as n goes to infinity? Because you can take limits even if it's not x. Bottom wins, which means plus or minus doesn't even matter. And how about the bottom one? Yeah, 2 over 4 or 1/2, and then well, it's positives over positives. It's just a positive one. So even though it's kind of like its own whole page of notes, basically, if you see an A sub n, that refers to a sequence where you plug in 1, plug in 2, plug in 2. We're taking a limit and using our degree test. Kiddos, 12-4. Okay, let's get out our homework spirals and look at 12-3. And then we're going to talk about the quest tomorrow and what's on it. Basically, 12-1 to 12-4.
You know, we're doing a class review.
There is one I think on your homework page. I think there's one on your homework page. But we'll call it bonus.
Oh.
Oh.
Not really.
Now he's like listening.
No, but it's good.
It is good. It is
It
good.
takes away the weight of the final.
Yeah, review is bonus. It's on the homework page. The review is bonus. Just 12.1 to 12.4. If there's any other sections, ignore them. I think last year we sadly got through like 13.2, even though it's not in our books. We made it up. I think in chapter 12, all we didn't get to was 12.5. Last year we got this section. We talked about the power rule, right? We didn't talk about the project rules. Okay, number 4 is limit the difference quotient. I mean, the definition of the derivative. Number 6, I think you were eyeballing for 6 and 8, right? You were eyeballing a graph. 6 was about -1. That was the slope rise over run. 8 was about -2 rise over run. Number 12 and 14, and basically most of the rest of homework. You were plugging into the difference quotient derivative formula. Ooh, is that something we should study for tomorrow?
Do we need to know the shortcut thing?
Only if you want to be able to check some of the problems. Does that make sense? Or if you want to maybe get a bonus.
Can you write it on the board? Oh my goodness. My existence.
Okay, we're in section 12.2 right now, right? Yeah. Okay. So, what is f prime? Yes. It can be called the derivative. What else can it be called? F prime, literally. Of x. Good. Slope of curves. What else? Something to do with the tangent line? There is one other way of describing this. Instantaneous rate. And what's his formula? That most of that homework is easy right now. What did you see? And as you plug in, because every good limit, what do you try to do first? And if it works, you're done when you plug it in, right? But what happens if it doesn't work?
Use divine creatively. Well, I don't know about this.
But why am I talking about keep going? Because what's going to happen when you plug in 0? You're going to have to keep going. So in this section, what you guys are seeing as you're checking your homework right now is that they had to actually take the function, plug in an x plus h, plug in an x, simplify, and then hopefully cancel something out, and then create it. It was your turn. Once you cancel something out, hopefully you can factor out an h, and then simplify something. Anyway, number 12, after that process, this one it was like a random k that you were trying to factor out. When you cancel out k, you just have 2. This one, wait, there is a huge jump from there to there. How do they go from this crazy function to that crazy function?
the rationalize,
Remember my trick? My trick was to multiply top and bottom by both denominators if there's more than one. See, that's how, but that's what ended up in the denominator, this guy and that guy and that guy. And then as you distribute him, this guy will cancel with that guy. And as you distribute him again, this guy will cancel with that guy. And when you simplify, you get the expression that they have. So it is a big jump, but my shortcut is how to make that jump. And once you make that jump, the h's reduce. Plug in. Now they do this weird like, hey, let's like do this whole difference quotient-y thing and then let's take a limit. I say just start taking a limit from the beginning because that's the formula. Long story short, plug in h is 0. Luke, did you have questions?
The only thing I don't understand is like the point slope form part of all
For a
this.
tangent line?
Yeah.
Let's keep going because I know there's more. Number 20. Same dealio. You're plugging into your f of x plus h minus f of x. You have a complex fraction. Oh, they did that huge jump, but it's really just my trick. Then hopefully the h's reduce as you're taking the limit. When the h's reduce, you plug and chug and you get the final. Since he is the derivative, we're able to quickly solve at 0 by plugging in and at -1 by plugging in. Number 34. There was a way to do it with limits.
Oh, no.
34. There was a way to do it with limits. But there was also a way to do it with the product rule. The product rule. No. The power rule. Sorry. We didn't do product rule. Was the derivative of c times x to the n. Do you guys remember how the rule goes? It's a shortcut. Ooh.
NCX n minus 1.
N comes down, c stays, x's power decreases by 1. And remember that solves for the derivative when you have a number times x to a power. And so let me show you this example right here, number, what was it, 34?
Yeah.
The original function was, and if you know the rule, you can use the rule if one of these comes up and I ask you to find the derivative, or you can use the limit one. No, it was just x squared, right?
X
Minus
squared
3.
minus 3x plus 4.
In order to do the power rule, you kind of got to think about if there are no powers written, what would the powers be? So since it's just 4, it's like x to the 0. Since it's 3, just x, it's like x to the 1. The powers come down, remember, power rule, the powers come down. So I have 2 times 1x to the 2 minus 1. The 1 comes down, 3 times x to the 1 minus 1. And then the 0 comes down, 4x to the, well, whatever, that's just 0. Guess we could say that. So then we simplify it. This is f prime of x. What's the new power of x? This one. 1 times 3 is 3. What's the new power of x? Oh, so it's not there. And that's plus 0. Same thing. The power rule is cool, you just gotta be able to do it. And it only works for ones where you have x's raised to powers. These weird like fraction ones, yeah.
Yeah, not
You have to learn other rules and okay, Luke was talking about tangent lining stuff. What's the point of tangent lining one? Number 40 is another plug and chug. They make a huge jump. It's a complex fraction. They're just tricky. That's why I was giving you some of those. So it takes practice to be able to make that weird crazy jump. Luke, here's 156, yeah? Okay. 56, parallel. Same slope. Wait, but I don't see the slope. Well, not if you don't write it in y equals mx plus b. Now, what's the slope of this line? So I need my function, which is, I think according to the problem, x squared plus 1. I need my function to have the same slope as -2. Well, how do I talk about his slopes? So you define his derivative. So they didn't give you the difference quotient formula. They didn't give you the power rule, but they're basically saying find his derivative. Can we try to practice the power rule? Yeah. F prime of x, bring down the 2, keep the x, decrease the power by 1, and you get just 1. What power does this have if there's no x raised? Good. Bring down the 0. Oh, what's f prime of x? What did all of this work end up saying? Okay, nice. But hold on, they're saying set the derivative equal to who? So I just say when does 2x equal -2? And that happens when x is -1. So now that I know a slope -2 and an x value -1, maybe I can make an equation of a tangent line. So I can do y minus equals, slope is -2. X is -1 minus a -1. How do I get the y? Take the x, plug it into the function and say, oh, cool. What's -1 squared? 1 plus 1. 2. In calculus, we would say stop, but you could also put y equals mx plus 1. So we also talked about tangent lines and the tangent lines. Section 12.4 was talking about horizontal asymptotes. We tried the same thing as to infinity or negative infinity. How do we do limits to infinity and negative infinity? We do a degree test, right? (12.4) horizontal asymptotes, limits to infinity. 12.3 derivatives and difference quotients. 12.2 use our simplifying tricks, whether factoring, polynomial division, simplifying complex fractions, multiplying by conjugates. And 12.1 ended in substitution, finding limits with tables, graphs, and then technically we led into with C. I think that's a pretty good sum of 12.1 through 12.4. So long story short, can you do the problems? The review will be online if you guys want it for bonus. Is that good?
You try to put it
Was for a friend, like a birthday present. So I was trying. It was during class too, and then
everybody loves it.
I know. She just hadn't been on concert for